Okay. All right. Okay. Well, hello and welcome everyone to the AxonOps Cassandra Support Clinic. It's brilliant to have you all with us today. We've got quite a few coming in. So just as you're joining, let me just share a little bit about what today's session is all about. And today we're going to be tackling your toughest Cassandra challenges. We're going to be diving into the real world troubleshooting issues. We're going to be exploring some of the most pressing problems users are facing right now. And of course, we'll be guided by our brilliant panel of Cassandra experts. Well, look, I'm Steve Benson. I lead the community engagement here at AxonOps, and I'm going to be your host for today's support clinic. But let me introduce the experts joining us today. We've got three of the best in the business. We've got John and Dmitry. They're both well-respected Cassandra committers. Some may even call them legends. And of course, we have our very own legend, Hayato, with us as well, CTO at AxonOps, an expert in Cassandra dating back, I think, to version 0.6. Is that right, Hayato? Anyway, great to have you all with us. Why don't we just hear a little bit about yourselves before we get going? So, John, why don't we just start with you first?
Yeah. Thanks. Thanks for the intro. I hope I live up to the to the reputation. So yeah, I haven't been involved with the Cassandra community as long as Hayato. I started in version 1.1. I think I was the first person to put CQL into production back at a startup like 12 or 13 years ago. But since then, I've been consulting. I worked at DataStax, the last pickle. I was the principal consultant there. Apple on the Cassandra team, Netflix on the database team. And now for the past 2 years, I've been independent as a consultant, helping people get out of tough situations, working on some internals, uh, lots of fun stuff. Yeah.
Great. Thanks, John. Well, it's great to have you with us. Dmitry.
Hi everybody. Yeah, my first version probably was 3.0, not that old,
Wow.
but still quite old. So I have been working with Cassandra for about 9 years. I'm a system architect in a tracker company. We use Cassandra a lot for different kind of stuff. And quite recently I've become a Apache committer for Cassandra.
Brilliant. Well, it's brilliant to have you with us, Dmitry. Hayato.
Hi there. So my name is Hayato Shimizu. So as Steve says, I've been foolishly kind of implementing a very early version of Cassandra in my naive young days, and yeah, we had lots of fun battling in the production systems. But yeah, I've been using Cassandra for various enterprises for quite a long time now, since 2008 or 9, and yeah, I've seen all of the kind of problems, issues, sleepless nights, and all of the scars from them.
Right. I hear the audience say we feel your pain, Hayato, but which is why we're at the clinic today, really, is primarily we are here to have these experts here, Cassandra experts here, to answer your questions, the challenges that you may have. What are the things that you're facing at the moment, the issues that you're facing? We're here for you. So just want to encourage you to use your Q&A box there. Get those questions in, and we're going to be taking those questions throughout the session today. Of course, with our experts, they're going to be diving into a particular subject matter, a particular challenge, and each of those are going to have some time to do that, but we're going to be weaving your questions in as well. Now, before we get going, we're going to just show one slide, aren't we, Hayato? And this is the only slide that we're going to show. Oh, let's just make sure we've got that all up there. Okay. There we go. Have we got that there? Can we just see that? I just want to just make sure that we've got that there.
Mm-hmm.
Okay,
I see it.
Okay. All right. Well, I just wanted to just let you know a little bit about AxonOps. For those that perhaps are a little bit new, we just wanted to share that AxonOps provides a powerful software and support for unified monitoring and operations across Cassandra and Kafka clusters, all through a single pane of glass. And frustrated by the lack of reliable tooling, our team of veteran data platform experts built AxonOps to ensure mission critical platforms stay healthy and resilient. And so I just wanted to share a little bit about who we are and what we do, and that we're hosting today's session. So before we literally get going, I just wanted to say it's fantastic to see so many of you joining us. We're going to be this is the first session that we've run, the first support clinic that we've run, and we're planning to do these every month. We're going to do them on the last Wednesday of each month, and so the next one is going to be on the 25th of June. But I'm going to share more details a bit later on that. Also, just want to give you a quick heads up as well that we are going to run a support clinic after dark section. That's going to be after our main section today, and it's kind of like an extra session really, and our experts are going to stick around. They're going to answer more of your questions, and we're also going to be joined by another special guest, Johnny Miller, and he's going to give us a live demo of AxonOps Workbench, which is an open source developer DBA IDE built from the ground up for Cassandra, and I'm going to share a little bit about that when Johnny comes on a bit later. So remember, we said the whole point of the support clinic today is really to have and create a regular platform for you to bring your support issues, your Cassandra support issues. So keep them coming in, and we're going to start to look at them in a moment. Keep pushing them up on the Q&A, and we're going to get going with the first topical Cassandra issue. We're going to bring it to the table, and John, you're first up, so why don't you take it away with one of the biggest challenges, or one of the hot challenges that you're seeing at the moment?
Yeah. All right. First up, got to set the stage. I can't go too big, but I got to impress. I think one of the interesting problems that I've been dealing with a bit recently has been the challenge of node density. And I've actually started a blog series on this topic. I think it's really interesting. Node density is really interesting if you want to keep the cost of your cluster down. Basically, the deal is that disk is cheaper than like everything else. So if you can pack more disks into a server and you can increase your node density, then your cost profile goes way down. And so I've been working on this with several teams over the last couple of years. One of them had a really interesting challenge, and for a little background, they have about 1,000 instances in AWS, and they're using EBS. So they're using GP3, which gives you 16,000 IOPS. And the one of the challenges that we ran into was they wanted to add nodes into their cluster, but when they decided to bootstrap, and they were using Cassandra 4.0, when they added a new node in and they had 4 terabytes per node, it was taking forever. Like they'd be waiting for days, and this thing would either fail, or it would just never finish, or just be really unreliable. And there's a number of reasons why we actually why you see a cluster hit that. In 4.0, we had 0 copy streaming get added, which allows Cassandra to ship an entire SS table over the network without copying it into the JVM, or if you're using encryption, it copies it into the JVM and uses a buffer. Really, really efficient way to stream. But they weren't hitting that path. And the reason why is because all the tables that they had created were set up with size-tiered compaction strategy. Now, size-tiered compaction strategy gets larger and larger SS tables. Now, one of the things that I, as a quick segue, size-tiered is almost always the wrong choice of compaction strategy. Like there's very, very few cases where it's good, but in almost all cases, it is it's like the worst possible of all trade-offs. But in their case, they were actually because they were dealing with EBS, and they were dealing with like sometimes a pretty high ingestion of writes. We couldn't easily just flip it over to LCS because the IO from compaction was so high that it would actually starve the reads. So they were in this like weird case where they're just like, okay, like what do we do here? And so they weren't comfortable switching to LCS. But one of the things that you can do with Cassandra 5 is use unified compaction strategy. And the reason why unified compaction strategy is so cool is because it will limit the size of the SS tables. And when you do that, instead of having them grow larger and larger and larger over time, you limit them. And basically what it means is, the long story short is, they're able to be streamed. More of those SS tables will be able to stream with zero copy streaming. So our expansion process went from wait 2 days, fail, start it over, wait 2 days. Maybe at the end of the week, you've got a new node in the cluster, to waiting a couple hours, and everything was super, super fast. There's a few other things that went into this. We actually did a storage engine level optimization for compaction that drastically improves performance, lowers IOPS usage, and really increases throughput, especially on systems like EBS. Those things in conjunction are allowing us to push density way higher on EBS. Now the limit is, can it keep up with your read requests as opposed to compaction? So basically what we have is a handful of things that are all kind of intertwined that aren't obvious. It's how the compaction strategy leaves your SS table size, which is what allows you to stream using zero copy streaming, which helps you expand faster. So it's like 4 or 5 topics that if you don't have your head wrapped around all of them, it can be really hard to understand how to solve this problem. So I actually wrote about this topic I have 2 blog posts, so I guess I can share it in the chat. Let's see. Does this go to everybody? I can't tell. So hosts and panelists. That's not everybody. That's just let's see. What I don't know how to share this in Zoom. I'm terrible at this, but we'll get it out. We'll get it out. We'll get this fixed. But anyway, the gist of this is that if you want to like read about some of the nitty gritty details of like how and why this works, and you definitely want to pay attention to the series, because I've got like 10 blog posts planned, and it's going to be deep in the technical details.
Yeah, I highly recommend reading John's blogs here, because this has really helped some of the kind of environments that I've been looking after as well. So John's been spending an enormous amount of time looking into the EBS and how it performs the AWS, all of the block sizes, the nitty-gritty of how it works in the cloud environment, and how Cassandra interacts with that. So definitely go through all of his blogs.
Yeah, thanks, Hayato. And Dmitry actually was one of the people that helped with that patch. I didn't even realize it. He backported it and put it in production.
I just wanted to mention it. The improvement which have been implemented for compaction, I have backported it to my fork for 4.1, and I've gotten a performance improvement even on dedicated solid disks. So it's valuable not only for Amazon disks, but even for usual deployments on premise. So it's really a good improvement for everybody.
And I think I remember you said it was like 10 or 15% improvement or something like that.
Yeah, I think it was about 15% improvement of compaction time.
Yeah. Yeah, when you're dealing with especially when you're dealing with write-heavy workloads where you're ingesting a lot of data, it's like you do not want compaction to fall behind. Like if it falls behind, you end up with tons of tons of tiny little SS tables, and your read performance gets worse over time, which actually makes compaction get worse. So really, it's like you want compaction to be always keep up, but not be interfering with everything else that you're doing. And it was really awesome to be able to get this storage engine level patch in. And Jordan West actually did the bulk of the coding on that. I did the evaluation and the idea, and he took it and was like, this makes total sense, and ran with it. And it was really great. I think it was a good collaboration with a lot of people.
So John, I'm guessing it's not only the compaction, but it also helps with the repair process, in that the Merkle tree generation of the scanning SS tables. Would that be kind of even better with this approach or change?
Yeah, we actually see an improvement in so for the just to get a couple things out of the way, there's a few code paths that use the same compaction like reader, the scanner. So repair is one of them, and it's the tricky thing is that Cassandra has traditionally not done a very optimal job of reading files off disk, and so this patch basically makes it so that we use way fewer IOPS, and we would do bigger bulk reads all in at once because we know there's sequential reads, so we just read all of it at once. That same exact code path is used in repair, but it's also used in range scans. So if you have a Spark job that like if you're reading like using the DataStax connector and you're on really it should help you with any system, but we found I think I got like a 3x improvement in range scan performance from this. So if you have a Spark job, just upgrading to 504 can actually really help you reduce your the time that it takes to run that job, at least the portion that reads out of Cassandra. So yeah, it affected, there was a number of code paths affected by it. It's like such an interesting patch because it came in, you know, as a bug in a bug fix release, but it actually delivers a major performance improvement and can significantly reduce the cost of running a cluster because you can just run denser nodes. You can shut a bunch of nodes down. It's great.
Well, I'm just sharing some of these links here. So, John, I've shared your one. Dmitry, shall I push yours out as well?
If John is okay, yeah, because it's also an article from John.
Yeah.
Excellent. Okay, very good. Well, just to
Yeah.
remind everybody, just to remind you all, keep pushing your questions in. We will take some soon, but we need some coming through. So if you've got any questions on what John's just been speaking about there, or whatever it is at all, whatever you're working on, something doesn't feel quite right, maybe you've got a question on the new 5.0 that's out and you've got some you're using at the moment and some questions around that. Whatever it is, we would love to tackle them, talk about them, and see if we can help you. So
Yeah, I have some interesting update about compaction logic because I noticed recently some another improvement is going on about using direct I/O for compaction to avoid pollution of page cache when you're doing this kind of full scans. I see the work is in progress, so maybe we will get another improvement in this area if we speak about disk I/O and compaction.
Yeah, that one, I think that one's going to be a good one too. The idea behind that, because I filed that Jira. The idea is when you do a normal read, um, you actually go through the Linux page cache. And so let's suppose you're compacting like 4 files together and each of them are 1 gig, let's say. As you read each of them sequentially, the data is being loaded into the page cache. So by the end of this compaction, you will have read 4 gigs worth of data, but then you delete the files. So you've essentially, like, to make room for that data, you've evicted 4 gigs worth of like potentially valuable data. And it can result in then you have to go to disk more and you read latency times. Your latency times get worse. There's a whole bunch of these like little optimizations that we can do that are just like good computer science fundamentals. This is an example. It's like you don't want to pollute your page cache with stuff you're about to delete, so we don't put it there. And direct IO is awesome because it allows us to bypass the page cache entirely. And then I mean, speaking about like latency, Dmitry, I know that you've done a lot recently looking at like lowering latency either through GC or through GC tuning and through reducing allocations on the heap, which also help reduce latency for a number of reasons. I don't know if you want to get into that. I don't know if it's a good time to
Yeah,
jump
it's
into that.
actually the story which I'm going to talk about. Yeah.
Perfect.
So would you like
well,
to
yeah,
do it?
you could jump in there, Dmitry, jump in, and
Yeah,
what we're going to
let
do,
me share my
we'll see if
screen.
we've got questions coming in. I think we're probably going to need to warm our audience up a little bit. So do you know what I might do, Dmitry? While you're getting ready, why don't we try a poll for our wonderful audience? Let's just see if we can get a poll up. We've got a couple that we've prepared earlier, as they say. So let's have a little look here. And I think we've got a couple of questions that may come up. Cassandra skill levels. Let's launch the poll. What is your biggest challenge with Cassandra. So there we go. So now is your time to select
I
the
can't
buttons.
vote. I can't vote.
You can't vote. No, the experts
Yeah.
can't vote. You're there to give all the answers. But we want to
Okay.
know from our audience. This is your opportunity now. So whilst we have it up, it's designing efficient data models. Is that the biggest challenge? Is it balancing performance and scalability? Query optimization, monitoring and operations. We're getting quite a few coming in now. Driver configuration, or is it something else? Maybe it's all of them, but it's going to be what's your biggest one? So we got at the moment, majority is balancing performance and scalability, and monitoring and operations. They're the two largest ones. So there we go, experts. That gives you a little bit of direction in terms of some of the conversations. But the guys, if you selected balancing performance and scalability, we'd love a question. Give us a question on it. If you've selected monitoring and operations, performance repair, some of those areas, what is it that really you've had a challenge with? Maybe it's something now you've got over, but maybe your question could help somebody else, even if you know the answer. So push it up there, and we'll do our best to answer. Right, I'm going to end that poll, and Dmitry, we're going to go to you. I'll just share the results so everybody can see.
Before Dmitry goes,
Yeah.
It sounds like chat is disabled. So folks, if you're trying to write something, put it in the Q&A tab.
Yeah. Use Q&A.
Yeah, someone just alerted me to that. Thanks, Sam.
Okay, so all your questions in the Q&A, and Dmitry, it's your moment to shine.
Okay.
Tell us
Do you see my
some
screen?
great knowledge, sir.
So is my slide visible?
Yeah.
Okay, good. Yeah, so I noticed that quite many people selected balancing performance and scalability, and this is my most favorable topic. I'm kind of obsessed with performance and always trying to find a way to make Cassandra more efficient, because while it's very scalable, I see still a huge room of improvement for performance of a single node, because less hardware, most efficient, less cost, and so on. So I'll talk about specific case. So let's assume you have a workload for your database. I/O is okay, load is stable, no spikes and so on, but you see that high percentiles for your reads and writes are high periodically, and all your tables are affected. It's not some single table, it's about every table. So the typical cause for this, unfortunately, it can be garbage collection. And if you want to monitor it, first of all, you need to check your GC logs, and there are also GMX beans, which can provide you valuable information. And if you do not collect by some reason this kind of statistics, please do it. It will help you a lot when you will start to do investigation. I also would like to mention another tool, not that popular and known, but it's helpful. It's called GHICAP, open source tool published by, I think, Azul guys, which helps you to track any kind of JVM poses caused by JC or maybe lack of CPU, VM movements, any kind of stuff. It measures the poses within your JVM. It can be attached to the agent, to your application, and I think it would be nice if we would have it as a part of Cassandra and metrics to be exposed out of the box without any additional movements. So I have a story created about it. Hopefully, I will try to implement it soon. So if you speak about GC pauses, what we can do here, first of all, I would recommend you to do an upgrade. If you're still sitting on an older version, please try to do an upgrade. What I've noticed based on my experience, 4.0 is better, 4.1 is better than 4.0, and 5.0 is the best as of now. And if you think that 5.0 is too young to use it in production, I think it's already stable enough. Please give a try to it. You will solve a lot of issues if you will just do an upgrade.
Yeah. I second that. I wholeheartedly endorse 5.0. It's a phenomenal release.
Yeah, so if we speak about what we can do from a development point of view, I mean, you're an application developer, how you can reduce the pressure to GC. You can try to reduce number of columns. If you have many value columns, you can group them together into frozen UDT. It will significantly reduce pressure to Cassandra from computational point of view and correspondingly to garbage collection. And another thing which affects garbage collection quite a lot if you have a lot of tombstones, because all of them are sitting in memory while we are doing a read, and as a result, we have a huge allocation spikes when you read such kind of heavy partitions. And what you can do from a configuration point of view here, it's you can move more data to off heap, ideally using off heap objects mode for your mem tables. And if you speak about 5.0, you definitely should try mem tables, where much more friendly to GC, and in general you will get a high performance improvement. I think John shared quite a lot about it during his live sessions.
Yeah, I agree with the try mem tables and off heap objects make a humongous difference. Even if you're using G1 GC, like you'll see a huge drop in your P99 latency. It's really remarkable. Yeah.
Yeah, and if you speak about garbage collection, yes, the default GC, I think still majority of people use it is G1, so you can adjust some settings. And there was a recent Cassandra improvement in default configuration about it by by increasing a new generation size, because a lot of data in Cassandra are allocated and for a short period of time, and there is no need to promote it and to increase cost for collecting these objects. So definitely you can make a few changes and get some improvement here. But at the same time, the newer versions of Cassandra, they support newer versions of GDK. I've just recently raised the topic about moving GDK 17 to production ready from experimental mode, because it's definitely stable enough to be. And even with GDK 11 and especially with GDK 17, you can use Shenandoah. In GDK 17, you can use ZGC, and these are low pause garbage collectors, which can give you significantly smaller pause time. It can be tricky based on my experience when you have some spike workload, like heavy repairs, big flashes, and so on, but you can tune them to behave more or less predictable from one side. And from another side, there are some improvements in Cassandra code as well, because how you can address garbage collection issues, you can just allocate less. And for example, I just merged maybe the last week an improvement about avoiding allocation spike when we are using off-heap objects during the flash time, because previously when we flashed mem table to disk, we allocated a lot of temporary cell objects, sorry, byte buffer objects, just to write data to disks. Now we can write directly from off-heap memory to disk without any extra allocations, and you don't have spikes, and correspondingly garbage collector feels better about it. And I hope soon we will get Java 21 support, and it will give us generational low latency garbage collectors, which will be the next step in this direction. And few pictures from real production, so you can see it was in real life. You can see the graphs from the GHICAP tool which I mentioned, and we can see that the latency, the pause dropped 2 times. First time when we switch from older version of Cassandra to new one, And the second drop was when we switched from G1 to Shenandoah. And now we got single digit poses for in our garbage collection. So I think it's more than okay for majority of applications currently. And still there is a lot of things to improve in Cassandra itself. We have some ideas how to reduce allocation for write path. John created a ticket about compaction. We have a huge amount of allocation for compaction, and hopefully we can push it fully to off heap and save a lot of allocations there. And I hope some improvements we will start to do for read path as well. So this is my short story about garbage collection.
Yeah, I definitely have found everything that you've said aligns with my experience as well. I think the interesting thing about garbage collection is there's been a lot of folks over the years who in presentations have said things like it's more of an art than science, which is kind of weird to me. Um, I personally just disagree with that. Um, I think that mystifies it too much, and it makes it feel like it's not accessible for people to know. Um, I think the things that are important to understand about garbage collection is that the collector has to keep up with your allocations. Like allocations are happening over here, and the garbage collector is going, "Hey, we got to get rid of these." And if the allocations are reckless, and if there's too many of them, and they're just like if they're happening faster than the collector can keep up, then that's when you see problems. That's why try-mem tables are so great because they actually do fewer allocations in the heap. That's why off-heap objects works really well because you're not putting that stuff on the heap, and the collector doesn't actually have to deal with it. Doesn't have to scan those objects. Doesn't have to promote them, because your pause time and your pause frequency are both related to your allocation rate. So the fewer allocations we can do, the more predictable our pauses get, and the smaller heaps we can use. Right now, we use a really large heap because we have such high allocation rates, so that you actually need a fairly large heap to be able to say, hey, we have a big working space. But if we can get to a point where we do, let's say, like the what you just mentioned, Dmitry, if we get rid of the allocations in the read path, and I know that you've been working on reducing allocations on flushing, well, then all of a sudden, if we end up with a very, very low amount of allocation, we can actually use much smaller heaps. That means that more memory goes to your page cache, which improves your latency even further. Like it's a huge series of like interconnected things. And it really, really, it can be difficult to kind of juggle all of it in your head if you haven't been doing this forever. But I think that it makes it worse when people make comments like, it's, this mystic art. It's like, no, it's not a mystic art. Like, it's allocation rate and collection rate, and that's kind of what drives everything. And you mentioned Async Profiler earlier, and that's the tool that you and I have used extensively to track down these problems. I know you did some of this on the memtable patches that you just contributed, right?
Yeah, I had some memtables patches, but yeah, the last one which I've just committed, it was about flashing, which I mentioned. I think it's avoiding new buffer allocation on the screen, that one.
Yeah, you use something with like a native cell, which lets you do the write and would bypass the heap, right?
Yeah, so it was we can now read values from off-heap memory and write them directly into file buffer without any byte buffers creation at all. So
Yeah.
direct copy from off-heap memory to off-heap memory. Yeah, and I fully support you with idea about reducing allocation. It's what I actually telling this the same, that when people ask me, okay, how can we tune garbage collection? I'm saying, no, let's do first. Let's try to reduce allocations first before touching any kind of GC settings. You should think about memory allocation. It's a primary metric to optimize. And then as a second round, when you've done what you can do, you can tune your garbage collection, because it's also if you tuned your garbage collection for a specific allocation rate, but then it changed, you will get new problems. It's just too fragile to try to optimize and tune garbage collector for a specific case, because if you have a workload changed, it doesn't work anymore.
Yeah.
And regarding memory allocation, regarding heap sizes, I think we will get a new next huge improvement when we will get a new GDK supported for Cassandra, and generational ZGC and generational Shenandoah will be available for us, because generational garbage collectors are more optimal in heap usage compared to flat ones.
Yeah, looking forward to that. Absolutely. I mean, when we migrated from GU1 to Shenandoah, I mean, we saw a drastic improvement in terms of the latency of the queries as well. And you saw the chart earlier. Everyone saw that chart that Dmitry shared, and that drastic drop is exactly what we saw. And it just gave me a massive smile in my face, when I saw this as well. But one of the interesting facts I found was that there's the metric that you collect from JMX and from Cassandra as well, of the Cassandra calls it pauses in minis, but it's actually not pauses. It's the total collection time is what it's presenting you, and not the actual pauses. So it's that name is slightly misleading from the configuration point of view. So I think the only way I've known so far to get the actual pause time was from the GC log itself. And I went through the code path of going down the JVM and then going to the Java, so OpenJDK source code. And there was nowhere I could find the way I could grab the pause time from the Java side of things. And it was in the C++. So I'm particularly interested in kind of looking at this Azul systems tooling around the presentation of the pause times.
Yeah, I think at least for Shenandoah, I were able to get from GVM GMX beans information about pauses as well. So I will try to find the name of the metric, and I'll share it after the meeting.
Yeah, that'd be great.
Yeah, I think that you can register a class to be called whenever whenever a GC pause finishes, and it'll give you statistics about it. But the funny thing is about it is I found this a long time ago, and every now and then I'm kind of curious. I'm like, what was that? And I go to look for it, and I take a couple minutes, and I can never remember what it was or like find it. I'm just like, did I imagine this? Like, but I'm pretty sure that
I think you mean where are GMX events about garbage collection, and you can register a listener for them and try to calculate the totals across an interval. So yes, I think it's also a possible way, and maybe such kind of techniques are used by Micrometer library to capture this kind of statistics and expose.
Great. Well, listen, guys, keep pushing your questions in, audience. Work these experts hard today. We've got one or two questions coming in, but before we go to those, we've got Raj that says same here. When we migrated to G1, saw dramatic changes in memory usage. So there we go. But who wants to take Sam L's question? Hayato, do you want to have a quick look at that one? And maybe just share that or read that out to us all.
I'm trying to find the questions. Sorry.
Oh, right. Okay. All right. Well,
expert. Oh, yeah, here it is. Yeah.
There we go. Q&A. Click that, and we're normally team users, aren't we? We use the Zooms every now and again. It always catches us out.
Yeah, so I didn't see any kind of difference. So the first time I went to G1 was, I think it was in Cassandra 4.0. Sorry, Shenandoah was Cassandra 4.0. And we used the Azul Systems Zulu JDK because that actually imports quite a lot of the great features into like the OpenJDK 11. Shenandoah was actually developed by Red Hat by, I believe it was Christine Flood and Roman, someone or another.
Let's just check the question, Hayato. Sorry to jump in. Do you want to just read the question out for us?
Yeah, the
Because obviously
question is
not
how
everyone
was
can see
CPU on
that.
Shenandoah versus G1?
Brilliant.
So the
There we go.
CPU impact on the switching from G1 to Shenandoah. So it really kind of I didn't see any difference in the CPU because the Cassandra was actually kind of was the biggest contributor to CPU utilization and not the GC. So I didn't see a big impact of the switch from G1 to Shenandoah.
The same kind of experience for me. I haven't noticed significant difference in garbage collection, consumption of CPU for Shenandoah versus G1. The only tricky thing which I think I mentioned during the presentation is these low pulse garbage collectors were more sensitive to spikes in locations when G1 can slow down your application less. They can really increase a pulse if you are running in some stress under the stress load. But if you have plenty of resources, they're much better. But if we speak about CPU usage, almost the same under normal load.
Great. Okay. All right. So Hayato, we're going to come over to you in a sec. Guys, time for more questions. Keep them pumping in. Let's find some really tough ones, maybe some real big challenges that you've had. I don't know what it could be. It could be whatever areas that you want around Cassandra. We're here to answer those questions. So to get you a little bit more warmed up, we're going to do another poll, if that's okay with everybody. So we're going to just see what kind of skill levels we've got in our audience here. So I'm going to launch this now. Hopefully you can see it. Can you all see that? I'm going to read it out. How experienced are you with developing applications using Apache Cassandra? There we go. So are you new to Cassandra and you're just here to learn the basics? Absolutely fine. Somewhat experienced, and maybe you've experimented with it. Maybe you're very experienced. I use it regularly. Or maybe we have another expert in the house that we don't know about. If that's you, click on the button. We want to know. So let's have a look. We've got most of the audience is somewhat experienced and experimented with it. And then we've got some also that are very experienced, use it regularly. That's great. Any comments from our experts at all on any of that? We don't have any more experts in the audience, John. It's
No
only
more
you guys
experts.
at the Legends
It's
today.
just
And
us. It's just
I'm sure if we
us.
ran this poll again at the end of the session, it would be a lot different, right? They'd
Maybe, yeah.
be all pushing up a bit more. Right, I'm going to end that. You can all see what we had. There we go. I'll stop sharing. Okay, all right. So keep the questions coming. We've still got 1 or 2 people coming in. If you just joined us, don't worry. We've still got plenty more to go. Don't forget, we've got Johnny Miller coming up soon. He is waiting in the wings. He is going to be showcasing for you today something very special. And in fact, I'll tell you what, Johnny, I'm going to give you 20 seconds. In 20 seconds, tell us what you're going to be doing in a bit. In 20 seconds.
I'm going to be showing everyone Workbench, a desktop application for DBAs and developers to use Cassandra.
Right, Johnny, why should I care about that?
Because it's very
I'm putting him on the spot now. Go on.
unserviced part of using Cassandra. This is quite limited tooling out there of varying degrees of compatibility with Cassandra. And the goal was to build a tool from the ground up that's for Cassandra, all the features of Cassandra. It's not just a JDBC shim and trying to make it SQL-like. Yeah.
Brilliant.
Actually,
and I know, Johnny.
Let me rephrase that one, Johnny. It's not for Cassandra. It's for the engineers.
I don't know, Johnny. You're very passionate about Workbench, aren't you? You've been very involved in the development of that and the whole progression of that tooling there. So it's brilliant to have you come on, and you're going to share that with us a bit later, yeah?
Yeah.
Do you want to say any other comments there before we jump to Hayato?
We have so Johnny and I, and talking about Workbench, Johnny and I have been talking about integrating Workbench into my EasyCast Lab tooling. So I've developed in open sourced some tooling that makes it really easy to set up Cassandra clusters for testing. We actually use it for my the Cassandra training that I've done. And when I do consulting and I need to, people ask me a question, I want to get like really detailed in my answer, and I want to be 100% confident when I tell people something. So this lab environment lets me spin up these these Cassandra clusters of any version, and really excited to bring Workbench into this. So you fire up a cluster and you'll just type Workbench or whatever it is that we end up doing, and it'll just fire it up already like ready to go, connect to the cluster. Yeah, once we get that in, I think it's going to be pretty exciting. Just I love integrating stuff that makes it easy to use great tooling like this. So I'm really looking forward to that.
Okay, thank you
Yeah.
for that, John. Well, there we go, Johnny. You got at least one person here signed up for it. Hopefully, after you've done your demo, there'll be plenty more interest from.
I've got a really good feature requested by Dmitry on our to-do list as well. So yeah, it's
Yeah,
Great.
I was very surprised that how fast you have implemented some of them, because I care a lot about usability, and I noticed that Johnny spends a lot of time to make it really useful and easy to use. Yeah, I appreciate it all.
it's been a
Good.
challenge with lightweight transactions, I have to say.
So, Johnny, we're going to let you get warmed up on Workbench. Okay, we're going to be back to you shortly. And Hayato, we're going to come to you in a second. But before we do, we have a question, folks. Are you ready? We've got a question. Are there any good tricks for audit login or any replacements being developed? As it currently is, it's useless if you run it in a high traffic system, i.e. any filtering per user, etc. Any comments on that?
My
John,
experience,
or Dmitry, go
I
on.
have it enabled in my cluster, but I'm auditing only DDLs and login operations. I do not audit any read or write operations because it's just too high load. And even if you can capture them quite efficiently, you still, I'm not sure if you have a system which will be able to analyze them efficiently, just because it will be huge volume. Compatible with the volume of data within your main system. So my experience, usually it's enough to have audit for specific operations like DDL and login successful and login failure.
Also, just to add to his question about filtering for users, when you configure the audit logging in Cassandra, you can provide a list of users to audit for or users to exclude from auditing as well. That's part of the configuration in Cassandra.
Brilliant. Okay, 5 minutes, Hayato. Sorry, we cut you a little bit short there. I don't know if 5 minutes is enough. Hopefully it is. But do you want to dive into some thought-provoking challenges, issues, things that you've come up against, support tickets that we may have coming in, anything that's hot on the channels? We'd love to hear your thoughts, Hayato.
Yeah, so it's always kind of a challenge to find a topic to discuss. There's so many different areas within Cassandra, and they're all interesting as well. But I thought I'd pick the most recent kind of challenge I've been experiencing, which is the I think it's just the general housekeeping and so on. But people are using still very old versions of Cassandra. So the latest I've come across is version 2.2, and that came out 10 years ago.
Wow.
2015, and still live in production, which is an amazing feat of engineering. It's lasted this long. Which is great.
I'll tell you what, Hayato, you've just given me a really good thought here. So if you just listen to that, what version are you using? Tell us on the Q&A. Just type in the version you're using, and then we'll see who's got some of the older ones, the newer ones. But a really good point there, Hayato. So yeah, if you're listening, just type in the version of Cassandra you're using on your Q&A. We'd love to know. Go for it, Hayato.
Going
So
from go ahead.
no, you go on.
I was gonna say, to me, it's wild because you know, unless you're running like if you're running a 3-node cluster, then you might not care, right? You set it up once and you leave it there and it kind of does its thing. But if you've got any amount of, like, if you've got a decent size cluster and you want to cut down, especially if you're in a cloud environment where it's like, you know, it's not like you're buying the server and then it's like the sunk cost. It's like you're paying for it every month forever. Um, it can massively reduce, like, just upgrading can massively reduce your cluster size. And again, this comes back to my node density thing. Um, and Dimitri's, like, when he was talking about GC, it's like you've got this, you know, we talk about the allocation rate and we talk about compaction strategies and streaming, and like it's all connected. And so going from 2.2, which, you know, maybe you'd say, hey, we're going to run like 1 terabyte a node, to like all the way stepping up to 5.0, where if you've got the disk capacity, you can do 5 to 10 terabytes per node without a problem. It ends up being a humongous difference in cost. Like, it's such a big difference. So if anyone's looking at like their cloud bill and they're like, how do we cut our Cassandra bill in half? The easiest thing you can do is upgrade and just get on the newer version, because you can, the cost savings can be absolutely massive. Yeah. Anyway, yeah. Sorry.
No,
Yeah.
absolutely. That's you know, one of the kind of points I was going to make, and that's, you know, exactly it. It will reduce the cost overall going from 2.2, and there's been so many improvements done by smart people like John and Dmitry here, and many other committers in the Cassandra community. You know, they have been working very hard to improve Cassandra over the years, and you know, I think, you know, I would highly recommend taking advantage of this amazing feat of engineering that's gone into improving Cassandra over the years. Yeah. So some of the problems I've been seeing, like with the old version of Cassandra, I just kind of, I remember those days of the gossip instability and things like that. And that has improved so much, especially for 0.0 onwards as well. The other aspects are things like the repair process have improved enormously. So operationally, you know, things have improved so much and makes it much easier, much more efficient to use. So some of the problems I've been dealing with are things like the repair had been done with sort of experimental repair, incremental repair feature in the past. And what that does is it marks the SS table files with the repaired at timestamps on them. And then subsequently, what people occasionally do is that run the sub-range repair, like using tools like Reaper, for example, and obviously AxonOps got that as well. But sub-range repairs what happens is when you do the sub-range repair against the incrementally repaired SS tables, start splitting them up. It was called anti-compaction, and start splitting up the SS table into repaired segment and unrepaired segments and so on. And you start generating absolutely hundreds of thousands of SS table files. I've seen this happen. And you know, I was watching this because someone's done these no-tool repair commands, and I saw the metrics of the number of SS tables going up and up and up and up and up, and I'm thinking, oh my God, what the hell's happening? So these are some of the kind of horror stories, you know, that happen. And you've got to kind of, you know, there's nothing else to do but to wait till you know, these files get compacted again, right? So you have to go around removing the repaired at timestamps of the SS table files. There's a no tool command to do that with, or sorry, SS table metadata command to do that with, you know, but yeah. So upgrade. There are so many efficiency improvements, operational improvements, operational ease of use, everything. So Cassandra 5.0 is actually a very, very, very good release. And as these guys are saying, it's ready for production. And you know, we should be telling the community to go with 5.0 now. I think it's had a lot more testing rigor put through 5.0 release. And you know, I'm really happy to say that, you know, say this is great, because in the past there's been some shoddy releases as well. And you know, so I'm happy to see 5.0, and yeah, people should be upgrading.
Great.
Yeah.
Hayato.
Yeah.
Sorry, Johnny. John, go ahead.
Yeah, I was gonna add to the incremental repair topic because I last year at the end of the year I dealt with this as well, and a team had put Reaper because they were using the Cassandra, the Kubernetes operator that DataStax released, and that comes with Reaper, and so it's automatically set up whenever I don't remember if it's automatically set up, but they set it up and use the defaults with incremental repair. And the thing is that if you just roll with a Reaper's incremental repair defaults, it creates there's this idea of like segments, right? It creates lots of segments, which are like slices of data to repair. And it's really counterintuitive because if you think to yourself, oh, I'll create more of these tiny slices, I'll do more of these like little bits of repair, you'd think that it would actually be helpful because you're like, well, I'm only doing this much data. Like, why should it take such a long time? But the anti-compaction part, it it basically separates the data that you're about to repair from the data that you're not about to repair. And so if you end up doing super tiny slices, you end up doing lots of anti-compaction. So the performance actually gets worse. In fact, this was so bad, the cluster that I looked at, the estimated repair time was 3 years. And they were just like,
Wow.
this is insane. Like, how can we run this? Like, don't we need to run this every 10 days? And I was like, yeah, like that's clearly the
That's
math doesn't
mad,
work
isn't it?
there.
That's
It's
mad.
crazy. And
John,
so
I would love to
oh,
come. I want to come back. I want to come back and I want to unpack this a little bit more because there's a bigger story here. But I'm just
huge. Yeah.
conscious. Yeah. I want to unpack that. All right. So we will do that. But I'm just conscious for those that have to go on the top of the hour. We have one very important poll that I would like everybody to have a quick look at. Now you've all had a chance, all right, to hear from our experts, to see the depth, the knowledge, and the expertise they all carry. And look, the question is, do you want to take more advantage of this? If you would like to book a session in and with any of our experts, then we would love to know. So let's just see if we can stop sharing on this. And what we're going to do is going to launch a quick poll. And I think I didn't share the results from before, so I do apologize. Let's just get back on that. Okay, here we go. All right, so I'm going to launch this poll now. Can you all see that? Can we see that or not? Let's see if we can get it launched. Here we go. Hang on, it's not launching. Okay, we might have to. Oh, here we go. It's because I was still sharing the other poll. All right, there we go. Look, I'm not an expert at all, particularly with Zoom, but I have found the next poll, and here we go. We're going to launch it now. Are you ready? So would you like to book an expert session in? It could be one of these guys. It might be somebody different, but it's going to be an expert. We want to know. And if you do have to go on the hour, then we want to thank you for coming. But if you can stay, it would be really good because we've got Johnny up next. And John, we're going to come back to you in a second. But before we do Hayato, could we get that last slide up? Because remember I mentioned at the very start that we're running these sessions, these support clinics are here for you, for your questions, or whatever the latest and greatest you want to know. We're here for you. We'll want to be here every month. The last Wednesday of every month. If we can just bring up the last slide, Hayato. What we've got on there is the QR code for the next session. So we're going to show that shortly. And let's just have a look and see how we're doing with our poll. And we're going to end that very shortly. So if you want to get in, maybe you do want to speak to somebody, maybe you don't need to, or maybe you're not sure, that's fine. If you clicked a yes, we will be in touch with you. Okay, so you can be assured over the next few days that it will probably be me. So I will connect up with you and we will get a slot in. An hour is the max, but we can do half an hour if it's just a few things that you want to cover. All right, so are you showing the slide, Hayato? Let's have a look. Do you want to just click so that it expands the whole slide? Because I think we can see the whole deck there at the minute. Let's just see if we can hit presentation slides. So if you want to hit the slideshow, let's see if we can hit the slideshow at the top there, Hayato, and I think you're good. and we're just going to click back one. I just want to point out a couple of things on this slide. So just click back one, Hayato, and you'll see on there, there's a few helpful links. Can we do that? Left arrow, and we should be there. But as we're on this slide, we've got Johnny coming up with After Dark. We're going to go on for a few more minutes. So if you can hang out with us, that would be fantastic. Just see if we can get that slide before.
Can you not see it? Because I'm sharing it.
Yeah, we can see the After Dark one. It's the one before that.
Oh, sorry.
That we're looking for. That's okay.
Oh.
And on there, some useful links, but the real key one is the next support clinic, which we've got coming up in a month's time. And we're just going to jump to the slide. There we go. If we can just bring that up as a presentation slide. Yeah, just if you could just hit the there we go. Fantastic. All right, so I'm just going to call out a few of these useful links. So maybe you're new to AxonOps and you just want to try out to monitor and manage your Cassandra cluster a little bit more. And well, you've got the opportunity to do that. You can do it for free. You need to click here. You can go up to 6 nodes. It's a great opportunity to really see the efficiencies that you can make there and some of the good work that the guys have been talking about today and how easy it is. To really manage that cluster. So top left there to click on that one. Now, as I said, you're going to be hearing from Johnny on Workbench. If you want to try Workbench out or find out more information, then you've got a quick link there as well. John, I'm going to give you 20 seconds, right, to tell us about the bottom left. What's happening over there?
Oh man,
that's your contact details, right? And why would they want to contact you? Because you're doing some cool stuff, right? Just shout out one thing that you're perhaps doing.
I mean, if you've got something related to performance and scalability, I'm your guy. I come in for a little while. I can help teams figure out exactly what's going on. I can tune systems, and I can train teams to get really, really good in a very short period of time.
Brilliant. Excellent. And that's great. Thanks, John. And we've got Book an Expert Clinic, which you can click on as well. So if you didn't go on the polls and you're thinking, oh, I wish I'd done it now, now's your chance. And we're going to let you do that on this today. Of course, we run other webinars. We run masterclasses as well. And you can get them on demand. But we want you back next month, 25th of June. You can't miss it. It's a special, special day, because it's not only our next session for our support clinic, it's my birthday. So, I mean, look, you've all got to come back and celebrate. 25th, not to be missed. Okay. And more importantly than that, it's an opportunity for you to put your questions and anything that you've got coming up. All right. So we're going to jump off of that slide. So thanks for that, Hayato. John, do you want to just unpack for 2 or 3 minutes on what you were just sharing there? And then, Johnny, we're going to bring you in for Workbench. And if you're still with us and you're wondering how long is this going on for, we're going to keep going for a little while longer. Most of you have actually kept with us. I think we've only lost about 3 people. So well done if you're still with us. Yeah, hang out some more and see what's going on. John.
Yeah. I think I was talking about incremental repair and how configuring too many segments can result in it being a complete train wreck. Yeah, so this was also amplified by remember at the beginning of our call, I was talking about that storage engine optimization. If you're on EBS and you're seeing slow repair performance, this can be one of the reasons, but you can also be seeing slow repair performance due to too many anti-compactions, or if you're running an older version of Cassandra pre 4.0, there was some really nasty bugs where you could run an incremental repair and then it wouldn't do it correctly, and you'd get flooded with thousands of tiny little SS tables, which could then take forever to compact. Like, you do not want to run an incremental repair before Cassandra 4. It's broken. Don't use it. And even afterwards, if you misconfigure it, you can end up with a situation where you're just burning CPU in disk and getting nothing done. You're literally just going to be churning through the same files, rewriting them over and over and over, and only repairing very small bits of data. So if you're running incremental repair, and you're using Reaper, you definitely want to make sure that you configure segment size. One of the things I really like that you guys provide with AxonOps is your repair service that kind of just takes that away from like something that you have to worry about. I haven't seen the same issues pop up there at all, and I have a few teams that are using AxonOps, and they're all really happy with it because they just kind of like let it do its thing, and it just works, which is nice. So I moved a bunch of people off. I moved a bunch of people onto AxonOps, but for the metrics, for the backups, and for the repair service, the custom dashboards, which I've shared before. I have some custom dashboards of my own that I've shared.
Great, that's brilliant.
Yeah, and
Thanks,
one
John.
additional reason to get a newer version of Cassandra, as John mentioned already, you are getting unified compaction strategy, and if you still use size-tied compaction strategy plus incremental repair, it's the worst combination which I've ever seen, because the problem about anti-compaction and copy a small amount of data to repair from the huge SS table slice by slice. In case of size-tied compaction strategy, it's amplified a lot, and you see your SS table actually copied maybe hundreds of times again and again just to compact a bit of data. Sorry, just to repair a bit of data from it.
Brilliant, great. Raj has just said he uses 4.1, by the way. I know we put that out there. We wanted to know what versions you use. If you've not told us yet, we'd love to know. So keep them coming. But Raj uses 4.1. So 4.10, actually, to be precise. There we are. Right, we are going into After Dark, and we've got Johnny Miller with us. Johnny, come and share some of the good things around AxonOps Workbench. Remind us again why this is so critical, and why we should all be going on the shortcut that I showed earlier to try it out and to see what it can do.
Well, should I ask Hayato
Over to you, Johnny.
Workbench slide again?
No, we forget the slides. Let's go straight into what you've got and the demo.
So yeah, Workbench built for Cassandra, not adapted from SQL, I think is that the strapline. But yeah, I mean it's been a kind of a real, I say, a passion of mine is always around the usability of for Cassandra, the ease of people to adopt it, figure out how it works and everything like that. And a lot of people, having that kind of desktop application that you can connect up to, you can query your clusters, you can generate queries, etc., kind of makes that adoption easier for people to use. So I really wanted to make a tool that was built for Cassandra, and yeah, it's built. It's still got a lot of work to do, but it's there and it's available for people to download and access. So I'll just briefly show you so if you want to download it, just go to Workbench, download. You can pick the thing. We will have it up on the App Store. Hopefully, it's quite complex to get that working soon. But you go there, you can download it. The project itself is completely open source. It's Apache licensed, and it's there. It's available to use, and I encourage anyone to come on, and we have just raise discussions if there's features you'd like to do. Oh, here's a discussion we started off earlier. CQL snippets for AxonOps Workbench. So come on if there's things you want to see in there, etc. Go ahead. But let me change my sharing. So once you download and install it and launch the app, what you get is a desktop application with what I'll start with is this concept of workspaces. Yeah. So a workspace is a way of logically grouping multiple connections that are relevant. Maybe it's your production environment, your non-production environment, whatever you like. So you can create these groups of connections on the various workspaces. And the reason we did that is one of my pet peeves is, going around wikis and trying to figure out all the connection information that you have. And so I wanted to get it in a way that I could check everything in to source control, but also in a secure way. So I'm not checking in passwords, anything like that. But essentially, what you get under a workspace is a set of files that contain, your connection information, configurations, SSH tunnel details, and those are perfectly safe to check into. I'm rapidly flicking around into source control. That here's ours. You can then check that out. Go in there, and there's nothing in there that I'm worried about around security or anything like that. But it all, and anyways, so you can. That's the first part of it, is creating a way you can manage all your connections, share them between your team, check them in and out of Git as well. And that was an important part to kind of make it easier for use. But once you have it set up and installed, it's all there to create your workspaces, give them new names. You can obviously configure where those workspaces are stored on the file system if you like, and you can also import. Sorry, I've got a camera thing in a way. You can import workspaces that you've checked out from Git. Just drop the folder in there, and it'll be in your thing. And we've got a feature coming to automatically check in and out of Git as well, as you're making changes to your workspaces, but it's on the to-do list. Anyway, once you install it, you've got actually two options to get started with. We have local clusters, and what a local cluster is, it gives you the ability to create I want to say my CAS4 cluster. You pick the version you like, and you can say how many nodes do you want. Obviously, if you're going to have a load of nodes, you better make sure you're doing this on a decent machine. And what it's doing is it's essentially generating a compose file, a Docker compose file, and then we use either Podman or Docker. It's up to you to start that cluster up and run it, and you click create. So it takes a while to download the containers and such. So here's one that one of the local clusters. You connect up there, and you can go ahead and start interacting in there, creating tables, all the kind of stuff you want to do there. It also has the bash thing, demos. That one's a little bug there. Gives you a bash prompt onto the Docker container if you want to play around with it as well. But as you can see, that ain't working. But anyways, once you connect up, when you're creating a connection, you've got a bunch of things that you might want to give. The obvious ones, the name, the data centers, the IP address. One of the interesting ones I've added in there is the time you want to use, because the drivers have two ways of inferring write time. It can infer it by the driver time, or it can infer it by the Cassandra server time. So I allow you to decide which time you want to use for your session that you connect up. On the authentication side, all the obvious stuff that you'd expect. And again, pointing this out, all of the usernames, passwords, these get encrypted and stored in the OS keychain. So it should be okay. And then also the ability to create SSH tunnels. If you have that line of sight into your cluster, if you've got a bastion or just straight SSH, you can create SSH and then connect over that tunnel automatically, and that gets created from the desktop as well. And all the necessary stuff that nobody seems to do these days is get their freaking TLS configured. But yes, you should be using TLS on your Cassandra clusters, and here's a way you can also connect up to it. So yeah, I see this. The two things I see so often is Cassandra clusters with no authentication enabled and no TLS enabled. Yeah. And the reason that's the case is the default Cassandra install is designed for ease of use, get you up and running and using the cluster straight away. But I rarely see people taking that to production, and it beggars belief that you would have a production database without any authentication any authorization. And in this day and age, without TLS as well, is kind of shocking. So
I still hear people saying it's in the private network, so it's okay. And things like Marks and Spencer's in the UK happens, right? I don't know if people have heard the news globally, but the massive retailer in the UK got hacked recently, and you know, they're losing hundreds of millions in business at the moment. So yeah, secure your database.
Oh, there's a quick question there from Raj Prakash saying, I saw many tabs in Workbench when he just entered into one of the workspaces. There's more tabs in that one, Raj Prakash, because that was the local cluster. That's the one in Docker. So you've got a couple of extra things you can do locally in there. For example, you've got actually AxonOps, he says. Oh, God, this demo, that isn't working either. Yeah, AxonOps running locally as well. So you go in, you connect up, and this is my regular cluster that I use for my webinar stuff. And from in there, you get all the good stuff you kind of expect to see when you connect up to date. They got the classic tree in there, and as you can see, this has been modeled around Cassandra. It's your virtual key spaces, your system key spaces, your application key spaces. You can also search across all of that metadata within there. So if you want to go, I don't know, size, let's find, there you go. You can search for size, tiered, and you can go, if you have a table name, that was probably not a good example. Let's try that. There you go. So you can jump through to find, here's my key space name or anything like that. So you can search across all of the elements of that tree. In the tree itself, if you look at, here's an example. So you can see we have logical groupings for things. You have counter tables. So if you right click there and say, create a counter table, we give you all the GUI to go in and do that, give it a name, give it a clustering key, and give it some counter columns, DD. I always put table comment in there because I love comments, and no one ever seems to use the table comments feature in Cassandra, but it's really useful for a kind of self-documenting your schema if you can provide a helpful comment in there. You've also got all of the extra options as well. You can choose to specify, override the defaults that are in there for creating that table. And the kind of ethos of Workbench is that I'm not hiding things from you. You see it. So simply put, you switch and there you go. You actually see the CQL that you can copy that into your own thing, and then you execute statements, and away you go. There's my counter table. It's being created. So it's so all that kind of stuff. And then other things you've got in there is we haven't done the right click action for views and indexes. We've done the right click actions for, say, UDTs. I had a good friend of mine who is massively obsessed with UDTs, and like hundreds and hundreds and hundreds of UDTs. So I gave the features around UDTs and the rest, so you can create them as well. So yeah, so let's walk into it even more. So if I go into, say, this is one of my tables there. I have the grouping of the primary key. I distinguish what is the partition key. This one doesn't have any, and this one here has clustering columns, and I describe what that is, and then all the other columns in there, all of the compaction options even there, and any other various table options you've got in there. Other things we've been doing a lot of work on the right click actions. It started as a labor of love and has gradually progressed into like a really a lot of fiddly rules and such. But as an example, you say you wanted to delete a row from a table. The goal here is to explain things to you while you're doing this. So you'll see lots of tooltips explaining things as well. And so, for example, here if I go, I'm going to delete where a column there. I can choose the different operators I might want to use for that delete statement. I can pick a column specifically that I want to delete in there. If I had a load of them, you can search the columns to find the columns that you want to add in there. It's also got the ability to set the delete data older than timestamp with a helpful tooltip explaining what that does, and a nice thing to pick it as such. And then if you're going into lightweight transactions, we provide you with some helpful stuff around lightweight transactions. So for example, okay, I want to do an if exists in there. And oh, here's a tip saying, okay, hold on, you're doing a write at 1, but you're doing your serial consistency level at serial. So you should not be doing that. You should be going, I don't know, quorum, yeah, and then it will do it. So we inform you. We won't stop you doing it, but we'll give you the information to know you should understand what that means. And again, we provide helpful tooltips on what those consistency levels actually mean. So here I'm explaining what serial consistency means. Similarly for the write consistency, giving you some helpful information on choosing that. And then again, you switch statements, you'll see it on there. And we chose consistency quorum. The session was already on serial, so we don't actually set it in the statement, but we put a little comment so you know it's in there. And then I go execute that statement, and it gets applied as well. Other things on the right clicks, we've got inserts as well. There's a similar to the delete, so you can have all those different values in there of the lightweight transactions, etc. This gets quite interesting when you're using nested collections, nested UDTs containing collections, containing UDTs, or lots of recursion in generating the CQL. So when you have if I have a table that has, let me find one that's got some, let's have a look at this guy. Evelyn, has got any in there? Columns. Okay, here's a good one. It's using frozen. So if I generate an insert statement on this, yeah, well, so this let me show you the table definition so you can see it first. Okay, so you see this table definition. It's got pretty strong, but this is the interesting one. I've got this frozen list of ints in there, and so if I want to generate the insert statement for this, I can go in and do one, pick a timestamp, or actually not, I'll use current timestamp, why not? And then I can go in and add all of the items I want into there. And this works with all of the kind of collection types, UDTs, populating the values. And I'll be frank, this is usually really fiddly when you're generating the CQL to do this. And this is one of my things I do like, is that I get to see the CQL. It's well commented. I'm telling you what the data types are, so you know, and then I'm constructing the corresponding things in there. And again, lightweight transactions in there too. Another one it does is, which not many people know about, is inserting as JSON or selecting as JSON. So you can construct, you can't use current date time in JSON. Here's a good example. You're doing an insert as JSON. You can't use the function current date time when you do an insert as JSON, so we don't display that. So here we'll pick a time. Okay, we generate the time, and again, you can add the same kind of stuff into it. Give it I don't know, let's give it a time to live, say 1 hour. I could pick an insert time. This is a feature of when you're inserting as JSON in Cassandra around what do you do with the columns that aren't in your JSON. And there's two choices. You can either just not pass them in, or you can explicitly set them to be null. So we allow you to choose that. Oh, there you go. Any column emitted from the little warning in there. And then we go in and you can see the CQL being generated with the JSON document in there with the default of null and a TTL. And wait, let's execute it and see what happens. There you go. Similar one is it will be coming as the selects as JSON. I don't think it's coming in. You can see the DQL is grayed out at the moment, but we will have in there. We've got inserts, updates, deletes, selects, all dropping in the next release in there as well. So a lot of that. More features. We've done a lot of work on query tracing. So if you go, if you turn tracing on, yeah, in there, run that. So tracing is set on.
I'm just going to jump in, Johnny, just really quick because we probably are going to need to wrap up soon-ish. We've still got loads of people on with us though, which is brilliant. So I don't want to kind of cut in too quick, but just conscious for those that do have to go. We don't want to keep you too long. So we probably got about another 5 minutes, but I want to give the other experts maybe half a minute each just to round up with final thoughts before we do go. But Johnny, yeah, carry on, sir.
So here's
It's all good.
with the
And
tracing.
we got a question. We've got a question as well. Don't forget.
Let me explain it then.
Go on, go for it. Go for it.
So there's a select coming back with a query trace, and I go in there. We provide you with a nice visual representation of that query. You can go in and filter by the necessary things that you want to filter on. You can filter by all of the stuff that's coming back. You can search. You can change ordering. All the stuff you might want to do to analyze that query trace. Other feature to point out is it's built on top of CQSH. Yeah. So simply put, we have this enhanced console where you can see there's a lot of stuff in here to like export things as CSV, PDFs, search across your result sets that are coming back, all the cool stuff we can do in there. But fundamentally, it's actually built on top of CQSH. So if I go in and do select star from, oh, there you go, it's a terminal there. So next. Roles, it comes back in the same way. So if you don't like the cool GUI, and I don't know why you wouldn't like my lovely enhanced console, you can step back to the 1990s and have a terminal client in your desktop app if you like. There's tons in there as well. We have this concept of schema diffs as well. You can take a snapshot of your schema, we convert it to JSON because it's deterministic in terms of doing diffs, and then you can save those snapshots locally, compare them. That's for I didn't change anything in production, and you go, well, hold on, you did change something in production in there, and these snapshots can be saved in your workspace directory, checked into your source control, so you have a reference. I took this schema dump this date. Come back tomorrow. You can do a diff to see if anything's changed. Yeah, I mean, there's also a little AI assistant in there if you like that kind of stuff. It's very basic, but you can ask it questions like, what are static columns? And that will come back with some helpful answers. We're going to be integrating the query trace into this as well to give you an AI analysis of that trace when we move on to V2 of our AI assistant. But yeah, so there you go. That's
brilliant, Johnny. Absolutely brilliant. I mean, there's so much to talk about, so much to demonstrate, so much goodness in there. I know we could go on for a fair time, and I'm sure most of the audience would probably stick with it as well, which is fantastic. I mean, most of them are still on still. So if you're still with us, hopefully none of you have burnt your dinner or missed any important meetings to go on to. We're going to be wrapping up soon, but I just want to say personally, Johnny, fantastic. Really appreciate you coming on, and I'm sure as well the audience do appreciate it too. We are just about to wrap up, but before we do, I just want to give some final words to our other experts before we do go. So any final comments, any final thoughts? We'll go with Dmitry actually to start with. Any final thoughts or comments at all?
I have two thoughts in my mind. First one, it's nice to see that I'm not alone with my problems. I hear very similar thoughts from John and Hayato about issues which I'm observing. So I'm not crazy. It's kind of everybody's issue. From one side, from another side, I see that Cassandra evolution is it's becoming faster. What I see in recent few years, there was a kind of stagnation before, but now I see a lot of features, a lot of new contributors, and hopefully the issues which we are discussing here, they will become a past soon, and we will get a better, newer, and easier to use Cassandra soon.
Brilliant. Well, Dmitry, thank you for joining us today. We really do appreciate all your input, and it's great to have you with us on the panel. Right, next up, John, final thoughts.
Yeah, so wasn't really prepared for final thoughts, but
I like to catch you out, you see.
yeah. I think one of the big takeaways from today that I'm gonna reiterate is upgrade. Like we've all said upgrade, but like I don't think it can be said enough. It's like especially if you're on a version older than 4.0, like if you're in the 2s or 3s still, it is time. Like the difference is insane. So the whole reason why the project was didn't move for 3 years is because we spent literally 3 years where we had a feature freeze and all we did was fix bugs. Like we just fixed bugs and made it work better. And now the testing that's part of the project is phenomenal. It's not like older versions where you'd be like, are we going to upgrade and like hit like some crazy issue? It's like the releases are like leaps and bounds better than they were in the past in the 2.0 or 2.1, 2.2, 3.0 days. 3.0 took forever to stabilize. It was a rough release. But since 4.0, like 4.0, 4.1, and 5.0 have been great releases, and we're already starting to kick the tires on what's going to be 6.0, and I think it's going to be the same deal. It's going to be spectacular. So yeah, upgrade people.
There we go. Upgrade, number one thing. Excellent. And I think Hayato, that was what you brought up. So it leads nicely onto yourself for final thoughts and comments.
Yeah, I mean, I think again, upgrading is kind of a really topic of the day, so it seems, and it does solve quite a lot of problems. It has solved a lot of problems for me, and so that's good. The other thing I want to say was really the community involvement. So there's the Apache ASF Slack channel. There's a number of Cassandra channels in there. So do get involved. Ask questions in there, or we're here to help as well. And yeah, so you saw the links that Steve had posted. Or if you want to get involved in the Cassandra project, I think they'll be more than happy to have you guys in there as well. So yeah, it'll be great to kind of get a lot of people involved in the community.
Brilliant. Thanks, Hayato. And you know where to find us at AxonOps, and also just to remind you as well, if you want to book an expert, one of these guys or another one in the team, then click onto that shortcut we gave you earlier and book us in. If you can't find that, jump onto the AxonOps website. You will find book an expert in it there as well. Right, 10 seconds. Johnny, you were last up. I'm going to give you the final words for today, and then I'm going to wrap.
Download and use Workbench.
Do it now. Do it now. There we go. You've been told. That's it. Excellent. All right. Well, listen, team, what fantastic, it's been to have you all on, and you all bring, different perspectives, but putting yourselves together, you've done really great today. I'm sure the audience have appreciated it, answered the questions. And listen, thank you, audience, as well, for your questions and all of your input and getting involved with our polls and sharing information. We really appreciate all your interaction as well. And don't forget, we are going to be back on the 25th of June for our next AxonOps support clinic. Come and check us out. If you've not got the link earlier, you can come on our website. We'll have it up soon. It will be there for you. All right. And we really do hope you found this session helpful. If you have, then share the next session with a few colleagues. Get them on as well. We'd love to see your teams with you next time. But until next time, take care, stay safe, and from all of us at AxonOps, and it's a big thank you. Take care. Bye.
Cheers.
Cheers,
Bye,
guys.
everyone.
Bye.